So you want to see how your dependent variables look like once you conducted your experiment. That is exactly what I'm going to show you today. So once you perform your experiment on 3 groups, you'll see that there are numbers on the side, numbers indicating height and mass. You can also see some qualitative data, the color of the plant, which does look different, and the number of leaves on the plant. All these things can be dependent variables, meaning that they are being measured and they depend on the thing that you manipulated or changed on purpose. Here, what I changed on purpose are the amounts of light that each group received, meaning that the amount of sunlight that the plant receives is my independent variable. If you go over to data, you can find a bunch of numbers, and I suggest using the line graph image to clearly see what your data looks like on a graph. If you can see, I am looking at plant height right now. Pot A, B, and C's information is all written down at below, and you can see that it's graphed per point, and the numbers are on a data table here. So cool. If you're looking at plant height on a specific day, these days go by 5s. So plant height at 10 days for group A, group B, group C are there as follows. Plant height at 50 days is here as follows. 25, it's all there. The same goes with plant mass, which means weight. The same goes with plant mass. It's also organized by day, by group that you've tested. Remember, you're only able to test 3 groups. If you have more than 3 groups, you're gonna have to do another set of groups. Now, if you're not doing this quantitative data, you're really gonna have to look at the pictures to do your qualitative data. For group A, I have like 2, 4, 6, 8, 10, 12. I also have 2, 4, 6, 8, 10, 12, but these are much larger, and I only have 2, 4 leaves over here. And that's just the number of leaves. You can also look at the color of that plant. Let's hop over to quantitative data one last time before ending, because a lot of you have grows quicker or grows faster, and that could mean one of 2 things. One, it could mean that one plant has, or one group has a faster height growth rate than another group, meaning that its height is growing faster than another. The other interpretation is that one group is growing faster in mass, in weight, than another group. To calculate either one, and this is important to be specific at this point, you need the numbers at specific days. So let's say I'm saying that the plant with most light grows the fastest in height because that's what it shows. But how do I grab those numbers? So you will grab the number at the day you're looking at. Let's say I say at the end of 50 days, the one with most light, 3 lights is pot A, group A, is the one that grows the fastest. To calculate that rate of how fast it grew in height, go to height and go to group A and look at this number, 51.6. Divide that by the number of days. So I'm saying 50 days because that's right next to it. And then you get your rate. So group A, the one with most lights, grew at a rate of 1.032 centimeters per day. Group B grew 1.162 centimeters per day. Now it's obvious based on our data and our math that group 2 or group B, pot B, grew faster in terms of height at the end of 50 days than group A. That is how you calculate how fast something grows, whether it means how fast it grows in height to a certain number of days or how fast it grows in weight or mass in a certain number of days. Look at the day that you want to look at in terms of your dependent variable. Make sure you're looking at the plant or mass of what you're looking at, and also the day and the number to find out how quick something is growing. So there you have it. We have a bunch of dependent variables we can look at. I taught us how to calculate how quick something is growing in terms of height and weight. If you have any more questions, please reach out and let me know.